Welcome to qnawire.
If you're shown a molecule, you might not be shown all of the electron pairs, the lone pairs, around the central atom, which means that you might be able to have different electron domain geometries based on the molecular geometry. So, like, for example, if you had something that looked like this, where you have three atoms all in a line, you have a molecular geometry that's linear, but linear can come from several electron domain geometries. So, of course, linear can come from something that's linear, something that's going to have two electron domains, and here each one would be bonded. But it could also come from something that has three lone pairs of electrons as well. And in that case, you can get a linear substance if it's trigonal bipyramidal. If you had five, if you had five electron domains. If you have something, though, that looks more like this, that's exactly a 90-degree angle. Well, this now, you've got something that's T-shaped, and T-shape only comes from one possible molecular, the molecular geometry T-shape only comes from one possible electron domain geometry, where you have two lone pairs of electrons here. So that's also going to be trigonal bipyramidal. Now, if you have something where you've got a central atom and you have six things coming off of it, six atoms, there's only one arrangement for that. That is octahedral with six electron domains. All of them are bonded, so it's also the molecular geometry as well. So we only have one possible electron domain geometry, octahedral. If we had something that looked similar, except we don't have an atom coming off of the bottom, we just have an atom coming off of the top, well, this has the same electron domain geometry, but it has a different molecular geometry, right? This is square pyramidal. And so what does this come from? Well, we have a lone pair of electrons here. The only way that we can have this structure is to have a lone pair of electrons there. So there's only one electron domain geometry, octahedral. If we were to take a look at one that, again, is similar in the sense that it's got the four coming off the center, but instead of a top and a bottom, we don't have anything there. That molecular geometry is called square planar. Now, that can only come from one type of electron domain geometry. It can only come if we have two lone pairs in addition around the central atom. So that is also an octahedral electron domain geometry. And you can see how they have essentially C, D, and E have the same general shape. We either have an atom coming off at all the same angles, or we've substituted an atom and that bond with a lone pair of electrons. And there's one more. And so if we have something that looks more like this, this one is a triangular pyramid shape. You might think that it is tetrahedral, but it's an unusual geometry, triangular pyramid. Now, I think that you could make the argument with that shape that you might want to call it tetrahedral. And if you did call it tetrahedral, that would be the same electron-domain geometry. But otherwise, it is a weird type of trigonal bipyramidal, where we'd have an extra lone pair of electrons there. But either way, if you're not familiar with the triangular pyramid shape, I would go tetrahedral.